Welcome to my basic electronic engineering presentation. My name is B.V. Raghuram from CSE AIML C section. My topic today is about mesh analysis. I will be explaining how mesh analysis is taken into consideration, what are the equations we use to derive the mesh equations, and types of mesh analysis. So to understand mesh analysis, we need to know what mesh is actually. A mesh, also known as loop, is simply a path through a circuit that starts and ends at the same place. For the purpose of mesh analysis, a mesh is a loop that does not enclose other loops. And the definition of mesh analysis or the mesh current method is a method that is used to solve planar circuits for the currents and it directly the voltages. At any place in the electrical circuit, planar circuits are circuits that can be drawn on a plane surface with no wires crossing each other. So with this, we have basic understanding of mesh analysis and what is a mesh. Mesh analysis works by arbitrarily assigning mesh currents in the meshes, also referred to as independent meshes. An essential mesh is a loop in the circuit that does not contain any other loop. Figure 1 below labels the essential meshes with 1, 2, and 3. Essential meshes for the planar circuit are labeled 1, 2, and 3 respectively. A mesh current is a current that loops around the essential mesh and the equations are solved in terms of them. A mesh current may not correspond to any physical flow current, but the physical current are easily found from them. It is usually practiced to have all the mesh current loops in the same direction. This helps prevent error when writing out the equations. The convention is to have all mesh currents loop in a single clockwise direction. Figure 2 shows the same circuit from Figure 1 with the mesh currents labeled. Solving for mesh currents instead of directly applying Kirchhoff's current law and Kirchhoff's voltage law can greatly reduce the amount of calculation required. This is because there are fewer mesh currents than there are physical branch currents. In Figure 2, for example, there are 6 branch currents, but only 3 mesh currents. Figure 2, you can see that the meshes are labeled and arrows indicate the direction of mesh current. Setting up the equations. Each mesh produces one equation. These equations are the sum of the voltages drops in a complete loop of the mesh. For problems more general than those include current and voltage sources. The voltage drop will be impedance of the electronic component implied by the mesh current in that loop. If a voltage source is present within the mesh loop, the voltage at the source is either added or subtracted depending on if it is voltage drop or voltage rise in the direction of mesh current. For a current source that is not contained between two meshes. For example, the current source in essential mesh 1 in the circuit above. The mesh current will take the positive or negative value of the current source depending on if the mesh current is in the same or opposite direction of the current source. The following is the same circuit from the above with the equations needed to solve for it. The following is the same circuit from above with the equations needed to solve the currents in the circuit. Once the equations are found, the system of linear equations can be solved by using technique to solve linear equations. Here we can see mesh 1 I1 is equals to Is, mesh 2 minus Vs plus R1 into I2 minus I1 plus 1 by Sc into I2 minus I3 is equals to 0 and 1 by Sc into I3 minus I2 plus R2 into R3 I3 minus I1 plus S Li3 is equals to 0. These will be the equations for mesh 1, mesh 2 and mesh 3 respectively. Special cases. There are two special cases in mesh current. Current containing a super mesh and current containing dependent sources. A super mesh occurs when a current source is connected between two essential meshes. The circuit is first treated as if the current source is not there. This leads to one equation that incorporates two mesh currents. Once this equation is formed, an equation is needed that relates the two mesh currents with the current source. This will be an equation where the current source is equal to one of the mesh current minus the other. The following is a simple example of dealing with supermesh. Here, for mesh 1 and mesh 2, minus Vs plus R1 into I1 plus R2 into I2 is equal to 0, and current source Is is equal to I2 minus I1. In this way, the supermesh equations are found and then solved in linear equation solving technique. Dependent sources. A dependent source is a current source or voltage source that depends on the voltage or current of another element in the circuit. When a dependent source is contained within an essential mesh, the dependent source should be treated like an independent source. After the mesh equation is formed, a dependent source equation is needed. This equation is generally called a constraint equation. This is an equation that relates the dependent source's variable to the voltage or current that the source dependent on, on in the circuit. The following is a simple example of an dependent source and how the equations are formed. For dependent sources, mesh 1 or loop 1 minus Vs plus R1 into I1 plus R3 into I1 minus I2 is equal to 0, and loop 2 or mesh 2 R2 into I2 plus 3Ix plus R3 into I2 minus I1 is equal to 0, and dependent variable is equal to Ix is equal to I1 minus I2. This will be found when the circuit is given and then solved using linear technique. Figure 3 and Figure 4 are examples for supermesh and dependent source accordingly. You can see that the markings are already given for supermesh, and supermesh occurs because the current source is in between the essential meshes. In Figure 4, we can see that Ix is the current upon which the dependent source depends, and these are the example for supermesh and dependent sources respectively. Thank you. I hope you have understood about mesh analysis and how to form equation and solve them using linear techniques. And hope that you have understood that special cases, supermesh and dependent sources. Thank you and have a nice day.